Hello. Now, today we are going to be looking at equations where we have fractions, and specifically algebraic equations where we have fractions. Our steps here are going to be quite similar in the beginning to how we would add or subtract fractions, but there's an extra bit that can help us in that we know that we can multiply both sides of an equation by any number we like, and so long as we do the same thing to both sides, we haven't broken the equation. So we're going to use a combination of what we know with adding and subtracting fractions along with that fact to make equations like this simpler. And as always with algebra, our final aim is going to be to end up with x is equal to a number. Always our aim, and it's going to be our aim here as well. And one of the big things in our way right now is that we have non-one denominators. We have fractions going on, so we don't want fractions in the end, so our job is going to be to get rid of them. So I said that we were going to start off quite similar to our adding and subtracting fractions, and what I meant by that is our first job is going to be to get all of these fractions with the same denominator. So we're looking, as we so often do, for the lowest common denominator of all of our fractions. So our lowest common denominator, we have 9, 2, and 3. The lowest common denominator is going to be 18. Our lowest common denominator is 18. We want all of these fractions to have a denominator of 18. Well, we're at 9 at the moment, so let's multiply by 2 to get to 18, and to keep our fraction the same, we're going to have to multiply on the top by 2 as well. And on our second fraction we're at 2, so we're going to need to multiply by 9 and do it on the top as well to get to 18, and then our 3 we need to multiply it by 6 to get to 18, and we must do the same thing. We must do the same thing on the top as well. So we multiply that out and we get 8x all over 18 minus 9x all over 18 is equal to 12 all over 18. Now we have everything over 18. I can write these two fractions here as a single fraction. So I can have 8x, add up my numerators or sum up my numerators, 8x minus 9x all over 18 is equal to 12 all over 18. Now the reason why we want to write a single fraction is equal to a single other fraction with the same denominator is it helps us to avoid mistakes with our minus signs. That's really why it is we want to have one fraction with the same denominator on either side of the equation. It helps us to avoid mistakes. And we can do a little bit of simplifying here. I have 8x minus 9x, so I have minus x over 18 equal to 12 all over 18. Now I can see I have minus x divided by 18 is equal to 12 all over 18. Well, that makes me think I could multiply both sides of my equation by 18 and I would get rid of my fraction. So I would have 18 divided by 18 would give me 1, so I'd be left with just minus x, and I would have 18 divided by 18 is 1, and I'd be left with 12 on the right hand side. So now I've gotten rid of my fraction, and I'm just going to finish solving this. I know I want to know what x is equal to, not what minus x is equal to. So I could multiply both sides of my equation by minus 1, and that will give me minus 12 as my final answer. But let's interrogate what we've done a little bit. We got the lowest common denominator for all of our fractions. Everything was over 18 now. I wrote it as a single fraction on the left hand side is equal to a single fraction on the right hand side, and I told you that that was to try and avoid making mistakes with minus signs that can come in more complicated questions. Then I multiplied both sides of my equation by the lowest common denominator, by what everything was divided by. That means that I effectively get rid of my fractions, because I have 18 divided by 18 and 18 divided by 18 that's equal to 1. So I get rid of my fractions by multiplying both sides of my equation by my common denominator. And that's going to be the pattern for all questions going forward, no matter how complicated the algebra gets. Now, let's have a look at this in a slightly more complicated looking form. So I have my two fractions here is equal to 0, and I know that any number, including 0, is secretly over 1 if it's a whole number. Now, I'm looking for, or therefore my lowest common denominator of 2, 5, and 1, which is 10. So I want to get 10 underneath all of these fractions. So I need to multiply 2 by 5, and therefore I must do it to the top as well. I must multiply 5 by 2. And I must do it to the top as well. Remember, I'm multiplying by a fraction here, and if you like, you can multiply by 10 over 10 here. It won't make any difference because this is 0, but for completeness, I'm going to write in that I'm multiplying above and below by 10. So, multiply out my fractions. 5 by 3x is 15x, 5 by plus 4 is plus 20, all over 10, minus 2 by 4x is 8x, 2 by minus 11 is minus 22, all over 2 by 5 is 10, is equal to 0. And I can just write it over 10 if I like. 0 over 10 or 0 over 1 is the same thing. It's still just 0. But I can write it over 10 if I like. Now I'm going to simplify this. Sorry, I've dropped an x. Be careful of that when you're doing a big question. So this should be 15x. Now I can write this as a single fraction on the left hand side, so it's all over 10. I have 15x plus 20 minus 8x minus 20. So we have to be very careful here. It's minus all of this fraction here, so it's minus 8x but plus 20. Minus of a minus is a plus, is equal to 0 over 10. Now I can do a little bit of tidying here. I have stuff involving x's, and I have pure numbers. So I have 15x minus 8x is 7x, plus 20 plus 22 is plus 42, all over 10 is equal to 0 all over 10. Now I have this done out. I can see that I can multiply both sides by 10, and that will get rid of my fractions, because 10 divided by 10 will just be 1. Writing out how I would sometimes write it out, I have a common factor of 10 top and bottom, so I can divide it out. And here I can multiply the right hand side by 10. I have 10 divided by 10, and I am left with 7x plus 42 is equal to 0. Rearranging, subtract 42 from both sides, because I don't want any numbers on the left hand side, I only want x's. So minus 42. Divide both sides by 7, and I end up with x is equal to minus 6. And that is my final answer. And again, you can see this question is more complicated than the previous one, but the steps are identical. So if we get good at doing this, we will be sorted. Now, this question here isn't substantially different. Let's have a bit of a practice at it. We have lowest common denominator. What's our lowest common denominator? Going to be of 5, 6, and 15. It is going to be 30. So I want to get 30 underneath all of these, so I'm going to multiply 5 by 6, and I must do it to the top as well. Multiply 6 by 5. And remember, I'm multiplying by a fraction, 6 over 6, 5 over 5, 2 over 2. So I end up with 6x all over 30 minus 5x minus 15 all over 30 is equal to 22 all over 30. Now I can simplify this now that I have common denominator of 30. So I have 6x minus 5x. This is a positive 5x, so minus 5x is going to be minus 5x, and minus 15 is plus 15. Again, we have to be very careful with our signs. Is equal to 22 all over 30. I can do a little tidying up here. I can see like terms. So I end up with x plus 15 all over 30 is equal to 22 all over 30. And I can multiply both sides of my equation by my lowest common denominator of 30. And that's going to get rid of my fractions, because 30 divides into 30 once. 30 divides into 30 once. You don't need to write this in if you don't feel it useful, but we are using the fact that we can make both sides of our equation 30 times bigger, and that's going to get rid of our fraction. So we have x plus 15 is equal to 22. I want to know what x is equal to, so I don't want that 15 on the left hand side. So if I'm at plus 15, I subtract 15 to get to 0, and I must do the same to the opposite side in order to keep the balance of my equation. And when I do that subtraction, I get 7. So x is equal to 7. So you can see the steps involved are identical, and if we can get good at following those steps, there's no problem. If we try and skip things and do things in our heads, we will make mistakes and it won't work out. So we just get used to following the steps each time, finding our lowest common denominator, simplifying our fractions so we have a single fraction equals a single fraction all over the lowest common denominator, multiply both sides by that common denominator. That means we go back to what we like, which is equations that don't have fractions in them. And that is all we need. Those are the skills that we need for fractions for now.